if you can go to the next slide, Monique. So the agenda we drafted is about what is the project about, tAIstify. Monique will explain that. There will and together with Rutger, he will explain the AI component of the project. And we really would like to have a round of feedback among all of you to check in whether there are questions or comments. And we would like to learn what triggered your interest in this project and what is your top priority to get out of the project. And that will really help us to further shape the project in the near future. And then we will provide you with a summary of the next steps and the timelines towards submission. So Monique, if you can take over.
I think I will. Okay. Well, welcome everybody. Nice to see so many interested people. Yeah, the need for tAIstify. This is also already in the slide deck that was shared with you. Is more the background. So why do we need the project? Well, if you go to food reformulation and processing for healthier, more sustainable products, sometimes this is accompanied by undesired flavor profiles. It can be caused by different factors, right? The texture and the flavor release properties may have changed. Also off flavor because of the processing from the raw materials. And all this together, if you have this less desired flavor profile, reduces consumer acceptance and market success. So flavor is key for consumer acceptance and for repeated consumption behavior. And that's why we want to do this project. And also to look at restoring the flavor profiles that cost now a lot of investment and time in resources, and how can we minimize that. So what can we bring when the project is a success? We want to get a better understanding of consumer acceptance, and we do this by integrating the product properties, flavor analytics and sensory data, and combine that with also knowledge and expertise on reformulation and ingredient interactions and fermentations when needed. And then we will work towards predictive models. And when we have this predictive model, we can use it, or you can use it, to accelerate the formulation process. The moon targets, so that's maybe a bit beyond the scope of this project, is really predict product liking. What we have as project target is to get a predictive model for flavor perception, and we relate it to liking, but really predicting liking and even repeated buying behavior, that may be a bit too far, but we focus on predictive model for flavor perception and combine it with liking. I think this brings me to Rutger, who can explain more about AI.
Thank you, Monique. Before I continue, maybe I thought it's nice if I personally introduce myself, since I see many unfamiliar faces. So my name is Rutger Vlek. I'm a direct colleague in Wageningen Food and Bio-Based Research of Monique and also of Joost and of Katrines. My role in the organization is the expertise leader of the team Data Science and Informatics. And personally, I have a master's degree and a PhD in artificial intelligence. And I've been working closely with my colleagues to formulate what you now see on the slides. I will talk you through the AI part of it, and also happy to answer any additional questions about the AI. So I thought it would be nice to start with a brief introduction. AI is everywhere, at least in the media. There's no escape from it, I think, at the moment. So I'm sure people have heard the term, but sometimes there's a little bit of confusion between various terms that you encounter in the media, and I wanted to clarify that. So artificial intelligence is quite a big area. It's the science as well as the technology that enables computers and machines to simulate human intelligence. Intelligent behavior like learning from experience, learning from data, recognizing patterns, understanding language, reasoning as well, and in general, solving problems or finding an optimum in something. So like route planning, for instance, is an application where you need that kind of capabilities. And then there's machine learning, and often artificial intelligence, AI, and machine learning, ML, are being used interchangeably, but that's not quite correct. So machine learning is just an area of artificial intelligence, and machine learning is dedicated to learning So it's about learning from data. And that's largely a science, although some people argue there's also some art to it. Essentially, programming computers so they can learn from data. That's machine learning. And I'm pretty sure you've also heard of deep learning, which made quite a big breakthrough in AI success in the last couple of years. Thanks to machine learning, and particularly thanks to deep learning technology, we now have solutions like ChatGPT, for instance. Those are enabled with that kind of technology behind the scenes. So deep learning is a form of machine learning, and machine learning is a form of artificial intelligence. But there are many more forms of artificial intelligence. And that is important to realize, particularly because we're in a scientific environment and we're not only dealing with data, we're also dealing with knowledge. We're dealing with academic knowledge. So I wanted to mention to you the concept of hybrids, where you create a model to make, for instance, predictions. And that model is driven partially by data with the help of machine learning, but also it's exploiting existing knowledge about a particular subject. And that can be highly detailed academic knowledge. And this is the area where we often work inside where there's a vast history of knowledge generation, a lot of academic knowledge on particular areas, but also gaps in that knowledge. So we try to close the gaps by learning from data with machine learning, but also have the traditional scientific methods and the knowledge generated to play a role in that and to couple them together to come to best results. Monique, can you advance the slides for me?
Could you, Rutger, do you hear me?
Yes, I can hear
yes,
you.
Could you, really interesting that slide. Actually, I'm not sure if it's okay to interrupt and to ask questions.
I think it is.
Yeah. Okay. Now it is. Could you please give an example of what you just explaining about that hybrid part? So the knowledge and the data. Do you have an example of what you achieved on this part, on this side?
Yeah. So there's a lot of examples I could give, but they require quite a deep understanding of a particular question. But maybe a simple example is, for instance, if you're trying to predict how an ingredient will change as a consequence of processing, it might be relevant to know the amount of fat that is in there. But it might also be relevant to have knowledge about the origin of the ingredient. So is it a plant-based ingredient or is it an animal-based ingredient? Because that's indirectly tell you something about the types of fat that you will encounter in there, how that types of fat will interact with your processing, and how that will affect the final product. So knowledge that we as people working in the food domain have in the back of our heads, that is not typically directly available for AI. So you have to make it really explicitly clear. Another example is that in the case of modeling, for instance, the way in which soil can take up carbon. That is quite an important mechanism for us to manage climate change, and understanding how soil can help to absorb carbon. There's a lot of modeling work done on that, and there's a lot of mechanistic models being made, so with clear rules based on knowledge, but those models have their shortcomings as well. And how can you leverage the proven scientific mechanisms in these models, but at the same time benefit from data that can now be generated on how soil is absorbing carbon, and defining mechanisms, AI mechanisms that make the knowledge unite with the data and add together. That is what I mean. Is that an answer to your question?
Yeah, it is. Thank you very much. Yeah.
It's good that you asked for clarification there. So that brings me to the next slide. What is the role of AI in this project? Why do we propose it? Why do we consider it? And I think there's multiple roles that it could play, but arguably the biggest one is in data analysis and modeling. So we're looking, and we'll come to the details later, but we're looking to make predictions about flavor, flavor perception. The mechanisms at play behind flavor perception are quite complex. They depend on a lot of variables. This is known. How exactly these mechanisms respond to particular variables and their values, that is not quite known. So we're trying to find, in this project, we're trying to find very complex relationships between variables, maybe interplay, probably nonlinear effects, patterns that are difficult to find with traditional statistics. Traditional statistics, they are usually limited to one-on-one mappings between variables, linear relationships, etc., etc. Also, we're looking to deploy the insights that we gain in a practical manner with the ability to make new predictions about new situations. What would be the flavor perception of this new particular product that we've never fully analyzed and never studied in a panel situation with a flavor panel? So for revealing these complex patterns and for the ability to really deploy the insights in a new practical situation, we're looking to explore AI. AI has shown in other areas to be really good at stepping up from traditional statistics and adding more capabilities of finding patterns. So that's why we think it's useful here. And ultimately, those kind of analysis and modeling efforts would lead to support decision making on formulation, product design, and optimization of products. But there's also a supportive role for AI in this project. As you can imagine, if we use AI that requires data, we need to be sourcing data, we need to be gathering data, and we can also generate data in the project. But there may be a lot of data out there already, but it might be scattered. So it might be scattered across scientific publications. It might be in different data sets out there. And it can be quite challenging to extract the data and to combine and harmonize all of that data to get into a consistent data set. AI can play a supportive role in that. So we have experience with text mining, for instance, technologies to extract information from texts. We've done that for protein digestibility information, amongst others. And also we have experience in harmonizing data sets, bringing data from various representations together. So someone expresses their data in kilograms per gram, someone else in a totally different unit of measure, someone else uses a different measurement method that can somehow be translated into the other. How do you cleverly unite all that data into something that you can work with? That's the second role for AI in this project. And the third is about data quality management. And I already mentioned the integration, so combining data. But if you rely a lot on data to build your models, you better make sure that the data is good. Because the general principle of garbage in, garbage out is very clear here as well. Your data needs to be good to obtain a good model. And artificial intelligence can help to reveal illogical data points, inconsistent data points, to identify outliers, and also with methods to handle missing data points. So what do you do? Do you maybe synthesize a data point that can replace a missing one? Things like that is a supportive role that AI can play into preparing the data that we actually need for modeling and analysis.
Next slide.
Next slide, please. So that brings us, I think, to the central question of what it is exactly that we want to model and what it is that we want to predict. So I think our current vision, and feel free to influence this, but our current vision is to focus on the food product as the starting point and the associated flavor perception of that food product. And we know that flavor perception is one of the factors that contributes to consumer liking. It's not the only factor. So there's many more in the red box, and I outlined them specifically to just illustrate how complex this mechanism is of consumer liking. So there's also the diet context in which you consume a product, and physiological factors, psychological factors, the cultural backgrounds, prior experiences, so many things probably interacting with each other that determine consumer liking. So we cannot directly predict whole of consumer liking, but we can at least work on predicting flavor perception and how it contributes to consumer liking. And unraveling that, I think, would be a beautiful step forward. So what needs to be happening in between, from the food products to the desired output of the flavor perception? You cannot just put in the food product in a model. You somehow need to provide information about the food products, and not just any information. I'm often joking that the color of my socks doesn't say anything about my personality. You need informative variables to help you with your prediction. So we've been thinking about what are the most likely information-rich variables that you can relate to a food product that help you with the prediction of flavor perception. And of course, we come to composition, what ingredients were used, how were these ingredients composed in the food products. The texture is important for the interplay with the flavor compounds in the composition. And we've listed them here explicitly, that the flavor compounds, you can consider them as part of the composition. We explicitly made them separate here. Of course, they play a primary role in what flavor can be perceived. And I think we're bound to identify several other factors that probably indirectly in interaction with the other factors determine flavor perception. So that's why we have the option X. Other variables that may or may not need to be included. They may be bound to specific product categories. They may be general across product categories. That's what we have to find out. But this is the general input that we wish to supply to the model. And here you can see the model as the wheel with the connections. That tries to describe the mechanism between the state of the variables and the flavor perceived. Can you advance, Monique?
The submodel?
Yeah. So this model tries to capture the mechanisms that translate the composition, the texture, and all sorts of other variables of the food product to the perceived flavor. So that means that if you can supply composition, texture, flavor, composition information to the model, you would be able to predict flavor perception. But there's a lot of intricacies in flavor perception, and some of them have to do, for instance, with release dynamics. So how is the flavor release happening over time? And those kind of mechanisms we could consider to model separately. So I started with a single model, but I think in practice we might be looking at a sort of composite of models, each catering for a particularly already known mechanism in this whole system. So that brings us to data collection, the data needed to come here. And Monique, would you be willing to take over from here?
Yeah, thank you. Rutger mentioned already that there are different ways to get data from the product for this project. So the input data. Let me see, some considerations before I go into what kind of data we can get. It's important consideration that the measures we do on the product, which are input for the model, that you can also do these similar measures when you want to make use of the model. So when we have a final model, you want to make use of it, it's important that you can also do these measures for your own products and continue with it. So that's a consideration we have taken into account. Yeah, and it may be that sometimes you need additional data to create a model for the submodels, which already was mentioned by Rutger. And also a consideration is that examples of measurements are product dependent, right? So some measures are relevant for beverages and not for cookies. So there are some specific product dependent variables which also need to be measured. Well, this is not necessary, all these animations. So moving on, so what are we going to measure? What is the product information? First, product composition. That is, for example, the ingredient composition where you start with. So this can be, we need to discuss the level of detail, like Rutger mentioned to me today. A potato is less informative than really the ingredients of the potato when you use the potato in making your product. So we really need to have a look on what level of detail is needed, and the more detailed, the more helpful for the model. So the ingredients, what you also have on your declaration of a product, but the chemical composition may also be relevant for some components because there are interactions of components with each other, which also may change upon processing and are not on a label of a product. The flavor profile that will be measured. I'll come back to that in the next slide. And there are texture, physical properties, texture properties, which are relevant, and that also a bit depending on the product type. So texture analysis, you can think of hardness, firmness, brittleness, elasticity, but also rheology, so viscosity, shear thinning, and especially for fluids, also particle size analysis may be relevant. So that is one source of input. And then we have the flavor perception. So you can measure the flavor profile of the product. And Katrien has listed here the kind of methodologies that can be used for that. Next to that, so this is the flavor profile of the product as such, but then it's important, so how is the flavor released? When you, for example, take it in your mouth and you chew on it. So we have different methods which are relevant for that. And this may also be input for such a submodel, right? So in the end that you don't need to measure all these characteristics when you have the model running. But for building the model, this may be very relevant. So it's in vivo and in vitro flavor release, flavor spec, and an electronic tongue that's more directed to taste. And then sensory perception, and then a focus on flavor perception. But of course, when you do sensory perception, you can also ask for texture and other attributes, but the project focus is on the flavor. The main methods we foresee are descriptive profiling and dynamic measures, especially when you combine it with the in vivo and in vitro measures. Gert-Jan, I see a question.
Yeah, question on the electronic tongue. So which type of modalities would be measured with that? Would it be sour, bitter? What Katrien, maybe you could elaborate on that.
Yeah.
I think that's mainly also depending a little bit on the product scope we are going in. Is bitter, will be saltiness, sourness, but also umami, and maybe also some aftertaste, what is a little bit relevant maybe for astringency and this kind of things. Also be aware that for the electronic tongue, it doesn't cover everything, so we also have to test if it's really related to the sensory part of it. But if it is for the typical thing we want to study, and the typical we want to describe, then it can be useful instruments. So.
Is it the receptor-based kit that was developed by Wageningen University? That uses
no, that's not included here, but that is also one what is on the back. But then we have to also to know a little bit more about in which direction we will go. You mean the tongue on chip?
Yes.
Yeah.
I will keep the rest for my questions later. I'll post them.
Yeah, but this is the normal electronic tongue, which is supplied by Alphamors and other companies, and has its restrictions, of course. Yeah.
Yes, now I know what it is.
But thanks. I know I have the relation with the other one, so it's not mentioned here, but it is on the background. If he can use it, it's possible.
Yeah, so this list is not a detailed list of everything we will do, but the options we have, and it's also not complete. It's just to give you an idea. Why doesn't it go to the next slide? Okay, then the product information. So I already mentioned that it would be nice to include a liking, so consumer studies with liking. You can think of ranking and preference testing and just about right skills. And as already was mentioned, consumer liking does not really predict also the repeated purchasing behavior, because there are a lot of more factors that are relevant there. And that was already a bit mentioned by Rutger. So the focus is on the good taste. So we would like to measure liking to make a link, although in the final briefing, what we can reach in this project is not predicting liking, but predicting the food flavor perception. But of course, we want to hint also if it refers to liking, because we want to build the model further in that direction. So we will measure it. That's at least the plan for now, right? Well, different pathways to impact. I think, Rutger, you can do this one.
Yeah, I'd be happy to. Yeah, so this is describing how the model that we're speaking of, how it could be used and how it could be valuable for you. But I'm also very much open to inspiration from your side to hear if we miss anything here or if you think one of these scenarios is not realistic. So let me describe them to you. I think in the basic sense, a model that helps to predict flavor perception could help with the screening of the consumer liking. So what are the chances that the consumer likes our product? And if you can reduce the risk of the consumer not liking the product, then you can steer much earlier in your product design cycle. So that is one of the I think lowest hanging fruits that we can address. If you go a little bit further, you might also wonder, can a model help us to understand which product factors actually influence consumer liking via the flavor perception? So which factors are in fact determining that it's currently perceived that the flavor is perceived as insufficient for consumer acceptance, and how can we maximize that? What do we need to change? What knobs can we turn? So getting that insight is also something that the model can support. And the insights that you can give also depend a little bit on the input data that we choose. So definitely changes in composition, it can reveal to you like these are the elements of the composition that are really directly influencing the current flavor perception. And if you would be able to modify those, then the perceived flavor is going to change maybe into the desired direction. Even a step further and a step more automated would be the use of an optimization technique around such a model. So if you imagine that this model is capable of taking a product information as input and predicting the flavor perception of that, you could also put in a vast amount of hypothetical scenarios for your product to design and each evaluate them, trying to find the optimum that brings you closest to a desired target flavor. A flavor profile. So if you set yourself a goal of either maintaining a flavor profile when you reformulate, or when you design a new product, you want to match a certain desired target flavor, then you can use such an optimization loop around this model to find your optimum and to find a proposed formulation, for instance, that best matches your target. So those are different ways. There's also scientific benefits. There's knowledge that we gain by trying to make such a model. If you're trying to make such a model and you're working with a lot of data for that, you have the opportunity to discover new factors and relationships in your variables that influence flavor perception or liking. You can also use the insights from the data to either reject or confirm, or even get new inspiration on hypotheses. So current scientific hypotheses might be rejected because of the things that we learn from the data that we collect in this project. Or we might get new inspiration for possible new factors that have a big influence on flavor perception. Also, we have the opportunity to reveal knowledge gaps and maybe gaps also in data. So that could help to direct future research into areas where it's most efficient, where it has highest value of performing research. And when it comes to modeling, what we learn is which kind of modeling approaches work and don't work in this situation. So a problem of this type, we're exploring what kind of modeling technologies can we use. There's a whole realm of AI technologies, which ones perform best in these kind of scenarios, given the properties of the data, given the properties of the problem, the properties of the mechanism that we know is at play. We'll learn about that, and we'll learn what is needed to expand the scope and the coverage, as well as the quality of the model beyond the timeline of this project. So of course, we have to constrain ourselves a little bit. We cannot make a model that works perfectly for all types of food products in a single project. So we'll make a start somewhere. We'll select cases where we start modeling. but we'll get the insights about how can we expand the scope of that model after the project, how can we further increase coverage and improve the quality of the model, what data do we need for that. And just for clarification, I wanted to share with you what I think are some of the factors for success in this project. And I mentioned the word data a lot, so it's also here. Data-driven technologies rely a lot on data, on the amount of data, on the quality of the data, whether it's noisy, whether it's data missing, whether it's data incorrect. It also relies a lot on the relevance of data. Again, the color of my socks doesn't say something about the weather, or maybe a little bit if it's cold. What also is important is that we have sufficient variability in the data. It needs to be representative of all the cases that we want to handle in the real world, and it needs to be unbiased. And biases have been discussed in the media when it comes to AI a lot. We don't want to replicate our national tax office in that. Complexity of the data is also at play, or rather the complexity of the data and the complexity of the mechanism we're trying to model. If you're modeling a really complex mechanism, you need a lot of data before you can understand what is happening inside. So that's data. Also, a factor for success here is to make use as best as we can from the knowledge that we do already have. We don't know exact mechanisms of how flavor perception comes to be, but we know a lot about it. So we better make use of that, because if we use knowledge efficiently, we will have to collect less data in order to make a viable model. And knowledge is also important in order to assess whether the model is any good. So we need to use our knowledge to assess whether the quality of the model is good enough for the application purposes. So validation of the model is here. And finally, the factor for success is a proper understanding of how this model could or should or would be used in a realistic situation. So understanding who would be using it, in what context, what would be the input to the model, how would the output being used? Would it be used directly to automate something? Would there be a person who is taking the output of the model as some kind of advice? How they interact with it? That is needed so that you can design the function of the model and the interaction with the model to best fit these cases. And finally, there's a lot of data that we need. I'll be really quick. 4 sources of data that we foresee. The first and the fourth data that we generated or can generate at VER. The second is data from public sources, scientific publications, public databases, information that we can integrate. And there's the possibility of taking into account data supplied by partners in this project. And I have to assure you that we will use this information to obtain insights, and we will use it to create a model. But we will not share this data in principle with other partners unless there is explicit approval for that. And the original data that was shared with us will not be reducible from the model that is the output of this project. So these 2 sections of data, a part we can share, a part we cannot share. What we also cannot share is data that we've generated in previous project at VER, because connected to that were other partners, each with their own interests, and there was a contract behind that. So this is how we handle data in the project. And this is back to Monique.
Yeah. And I think we need 1 more minute, and then we have time for discussion. So this is a workflow you've already seen in the previous slide. So this is already starting towards the work package, right? So we have the data, we have the modeling and the evaluation, and the evaluation gives again data and can be used in the model. So we have now come up with a suggested project structure with 4 main work packages. And the first one is really important, because that's a work package where we together define, okay, what are the relevant product measures, which attributes are we all needed, and get a really broad set of parameters which we can use as input for the model, and also come up with clusters of product. And then there will be 1 product category selected to generate the initial model. Then we start data collection in work package 2. And there, the third one, partners can in parallel start collecting data for other product categories. I can imagine, because you are all with different product categories interest, that we started with product A, category A. You do in the meantime all the data collection, and as soon as we have the model running, we can make the model running with your data for your product category at least. Well, maybe not that easy as I'm saying it, but that's the idea. So where package 3 is on the modeling and 4 is on the evaluation. I think now it's time for the discussion. Stop sharing.
Yeah, maybe the first question, are there any questions based on the presentation of Monique and Rutger? So maybe you can raise your hand if you have questions. Let's see one, Serena.
Hello, Serena from Loacker, Sweet Biscuits Company. I have 3 questions. Maybe I can do them in order, and then you can answer. So the first one is that I can imagine that we are going to have some iteration of the model in a sort of agile philosophy or approach, better. The second one is that, do you imagine already which kind of data do you need from partners, or probably, as I imagine, it depends on which kind of partners do you have then in the consortium? And then the third one, that it's probably for me the most unknown question or difficult one, because I think I have a gap, because we are starting, I mean, the output is the perception of flavors, and you're going to use this to have a proxy or to predict the likeliness. But then I saw that out of scope is or are the cultural differences or the psychological mood of people. And so I was wondering, because if you exclude the cultural, I mean, all the cultural stuff, you cannot see, because, for example, one food is perceived as good for example, an Italian, because I'm Italian, and not good, for example, for an American, and vice versa. But then there are some foods, for example, some kind of pasta or pizza, that are perceived more or less as good. Then we have differentiations. So my worries is that in my mind, I would try to have a model where if I put inputs like ingredients, our standards, let me say, like clean label, ingredients and whatever, and our standard of goodness, that it's very difficult, I will have a recipe, the perfect recipe. In this case, you will like limit the differences between products and companies and brands. So I don't know then that the differentiation is going to work in the input. So, I mean, my worries is that if you're going to work on only, it's not only because it's an important thing, on your flavor perception, I'm not sure if we will arrive to goodness, standard goodness, because it's difficult. Sorry for the long question, but it's complicated.
Shall I start answering, and Katrine, Rutger, you add if I forget something? Iteration of the model, yes, that is the idea, right? So that's a yes, that's a simple question. What kind of data do you need from the partners? Yeah, well, any data which give input on the things we showed, so the product composition, the flavor, the sensory perception and liking, any data for that are relevant. And the gap you mentioned, yeah, I understand your worry. But if you also want to take into account all these cultural differences, I think then we need really a much longer term project. And it's also very different between the product categories. So what I can think of, if you know, for example, let's say you have a kind of product which you know that's liked very well in Italy, and you want to reformulate it to less sugar. then you can take that product along, right? And you want to have similar flavor perception, then you come close to liking. And of course, we can measure liking, or in this case, preferably you would measure the consumer liking. So you learn from that as well, but it helps you to come close with the flavor perception.
And I think maybe to add on that is I think there is already in this field also something known. So at one side you have a flavor profile in which which in the database, and this flavor profile is what you already say, maybe positive for Asia, but it's maybe negative for Europe or the other way around. So, but bringing in then this knowledge of what is already known in literature, etc., between the cultures, then you come a little bit closer to the liking. So it's we already said we're going in a direction. We try to come as close as possible, but to have 100% covering, I think what also Monique said, that will be difficult. Yeah.
Okay.
Is that helping a little bit?
Dario, another Italian guy.
Yeah, hi. I'm Dario from Unigra, also Italy. We are an ingredient company. No, I actually have two questions. I wanted to acknowledge that yes, the project sounds very exciting and very challenging, and I totally relate to what Serena was saying. So I guess this kind of standardizing perception is kind of a very, very difficult exercise, but I mean, it's challenging, but probably not impossible. What I wanted to ask is actually about the consortium itself. Like, I guess I mean all of us are here because we showed some interest and also because we got in touch with you and so on. But how would, according to you, how would the consortium look like? I mean, I was thinking, for example, for this kind of experiment, would formulated products, like highly formulated products, like with a very, very long list of ingredients, be more interesting? I'm just saying interesting from a scientific point of view. All products are nice, all products are good. But for example, also just if I have one ingredient that I can process in 1,000 of different ways, that also can provide me with a lot of different data in terms of perception, because if you think any raw material, I can process it in many different ways and get something completely different. So yeah, I'm thinking about a little bit what are the extremes, and I'm guessing like at some point some boundaries would need to be set, because otherwise this would be totally out of control. I don't know how to say this. Thanks.
You want to answer that, Rutger, on the boundaries, or shall I do it?
Yeah, maybe you can help me. My first remark would be that scientifically, we're aiming to find a path forward with flavor modeling. So as a scientist, I am interested in learning about all the possible variations that occur in the real world, variations in complexity of food, variations in how it is composed, even variations in the same ingredient that come from different sources. And the more variation we can capture, the nicer, I think, for the ultimate goal of flavor modeling. But what is feasible within this project, we have to really cleverly scope. So we have to find some kind of common ground between the different cases that we're trying to work on in this project. At least enough of a common ground that we can build a sort of unified model for all these cases. And I think that's where our challenge is. So, and here it's worth referring back to the presentation I gave about factors for success. If you have a very complex product with a lot of different ingredients, there's a lot of potential variables that could influence the flavor perception. Because it's so complex, you need more data to make a viable model to work in that situation than you would in a much simpler case. There you could get away with less data for flavor modeling. So this is something to take into account, but it is really difficult from my position to quantify what is the minimum level of data that we need. There's no hard science behind that. So,
but not necessarily a very long list of ingredients. That's the message, because then we need more data.
Yes. Yeah.
But maybe also a little bit the other way around. You can have a lot of different ingredients, but you can also use the model. You want to have something you want to make, and maybe the model tells you from all the ingredients which you need to be successful in this case. Yeah.
Yeah.
We move to Gert-Jan.
We don't hear you,
So,
Gert-Jan.
yeah, okay. Can you hear me now?
Yeah.
Yeah.
Okay. So having had some experience in not AI modeling, but modeling like chemometrics modeling, one thing that I remember that was already quite relevant in the beginning that you shared, Rutger, that is the quality of data. So the more different data sets you're getting in, the more rigorous we need to have a look at the data that's going in if you're going to use that in your model. So that's question one is, for whatever data that goes into the model, do you guys already have a set approach of how you're going to look at that? Whether the data that will be supplied during the project is of the right quality so that it makes meaningful sense once you get the data in. So that's one. And I asked that because I had some bad experience in the past where we did this type of chemometric modeling. We worked with actually back then a commercial partner, and they said, well, your data looks good. And they did a very quick check. But afterwards, what they found out is that the data that we use and the data that they gathered was regrettably not interchangeable. They couldn't make heads or tails out of that afterwards. So my question is, do you have a methodology to check what, once you get a training set of data from the partners that would join, that you can fairly quickly check, oh yeah, this is good enough for the model, or this, no, we can't use that. That's question one. And question two, I would echo the people who went before me. I think it's really vital that once we work together on a project like this, that we're very clear of what will be generic data that will collect and that will be used for all of the modeling, and which is basically your anchor throughout the project, so that you know this is always the same type of data. I can rely on it, and what you believe is not inside. So what would be with the partner? So the more clarity you could give on that, I think that's very helpful. And I think the generic answer, if you could go in a little bit more, be a little bit more prescriptive on that, that would be helpful. So for instance, all the consumer data, will the partners collect that? If so, how are you going to handle the different ways of how consumer studies are done? Or is that something Ver does? You know, a little bit of clarity on that level.
Shall I start with the question?
And then
you have a third question.
And then I have a last one here, because I'm pretty sure if we link into this, I'm pretty sure the third one I'm going to be asked by some of my colleagues. There's also some commercial modelings out there. Example is, for instance, the digital twins from the company Food Pairing. Could you have a look and how this model is different from any of the commercial material out there, and how it will build on top of that? Because I'm pretty sure most of the companies, once they say, hey, this is an interesting proposition, they will get challenged on their ways. If you could have a look how those commercial models differ from this one, that's good input. Those were the only three. Sorry,
only three.
I had a lot.
I can answer question two, and then I give the others for Rutger. I think I can answer. I hope I can answer. So you're asking about, for example, consumer data or other data, and actually that's the question on how to harmonize the data. So of course, if Work collects all the data all at the same manner, we are sure we can use all the data because they are measured in the same way. But then you have a limited number of data. So what Rutger already mentioned in his slides is that we can also get data from partners, from literature, etc. But then you have different scales, different attributes, description. So we plan to really spend some time in this project to see how we can still make use of these data and which data we cannot use, right? So sometimes the attributes have different names, but they mean the same. So how can we check that? And that's part of the learnings that Rutger mentioned, which we can do. So we would like to have data from literature, from partners, from within the project. That can be consumer data, can be flavor data, can be products, ingredients. There's at this point no limit on it, and in work package 1 we really want to focus on these questions you just asked about this. So no answer but an answer.
Maybe also using there also the knowledge which is already in,
Sure.
to judge
Sure.
what is the data there. And secondly, there is also some software I think, Rutger, we can use just to see and how far it fits in the model we are doing, or is it separated from the rest. So there are possibilities in my opinion, but that's maybe also a little bit more for you, Rutger.
The question on the commercial modeling, I give it to you, Rutger.
Yeah, that's okay. I can tell that I was not aware of the particular product that you mentioned, so we will look into that and we'll see how we'll discriminate from that. But maybe it's good to point out that we are in connection with other parties that are also active in the field of AI flavor modeling, particular universities and AI institutes, and we're trying to collaborate on the way of working. So not necessarily on the types of products, but on the way of working, how we model this, learning from our each other's best practices. So this is happening in parallel to this project. And if this project is going to be granted and running, we will maintain links throughout the runtime of this project with other initiatives to make sure that we learn from each other's experiences. And we'll double check.
That makes a lot of sense. The main thing that would be helpful to get as a feedback here is what would be the distinguishing new and improved features of the model we're building here. And it could even be this is free source, whatever you do at food pairing is not free source. I don't know what the benefits are, but basically make a bit of a picture what would be the main benefits of going to a commercial model versus this.
I think we can do, because also food pairing has its limitation, but it also has its positive sides, and so it can even be that partly it can be included. So that's also up to Rutger, but let's have a look to it, because I have some experience with it. So
yeah, and then your first question, which I thought was really relevant, how do we manage data quality? And there's a couple of things we can do. But the most important point I wanted to share with you is that we need to talk about the data, because if you share with me a data set, what I see is numbers. What I often don't get to see is the exact meaning of those numbers. There's probably a unit of measure and there's a quantity in your data sets probably described, but the exact conditions under which you measured, they are usually shared with the explanations that come with the data sets. And I think that is where we need to be really careful. And this also comes back to what Monique mentioned about the different ways in which flavor perception is being measured, how attributes are defined and described and communicated to panels. And I've understood that there's no absolute measure of these attributes. So they're grounded essentially in natural language, which means that we have to find some way to measure how close are they? Are they identical? Are they similar-ish? Are they very distant from each other? Are they completely different taste dimensions? And I think this requires, like Monique mentioned, our efforts. If we succeed in a methodology that allows us to unite the different definitions of attributes across multiple studies, I think we've made an important step forward. So I think it's worth spending our time on. And then when it comes to actually checking the data quality of the numbers that we receive, we intend to implement statistical and logical measures. Also, I want to mention that AI in the last decade has made quite a leap forward in how the influence of noise in data is influencing the learning process. And this probably will become very technical, but the problem of learning from data is often the influence that outliers can have on your entire model. What you want is you want a balanced influence of each of the data points that you feed to your model so that they contribute to a sort of general picture that is valid across all of the data, despite the noise that is on top of all the data points. In technical terms, this is called regularization, and regularization techniques in the last years have made quite a leap forward. And particularly for deep learning purposes, it's very important. So AI's ability to deal with noisy data is becoming better and better. Whether it's enough already for dealing with the data that we'll encounter in this project, I dare not say.
I think
So that is something we have to discover.
Important objective of the project, right? I'm looking to the time. We only have 2 minutes left. We have two raised hands, and I definitely would like to present the timelines. Can you quickly put up that slide, Monique?
Yeah.
So I start with that, and then we afterwards continue with Halak and Shannon. So there it is coming. So at this very moment, we are the project is open for partner recruitment. Everybody around the table today indicated that there is interest. What I would like to understand from you in the coming 2 weeks, so at the end of June, so based on the discussion, based on the presentation we had today, is that interest still there? And just a simple email stating that there is interest is sufficient, and I will follow up the meeting today with instructions about the next steps. Because at the end of June, we would like to make a start with writing the proposal, which needs to be submitted September 2nd, I believe, not 1st, 2nd. It's a terrible timing just after the holiday season, always annoying, but it is what it is. So at that point of time, September 2nd, we need some kind of firm commitment. At that point of time, you have seen the proposal where we describe in detail what the project is about, what type of activities we're going to execute, and which partners showed that interest. And at that point of time, we need to be allowed to include your company name and your contact details in the proposal and submit it to the tAI agency. In October, November, we will learn whether the subsidy is granted, yes or no. If that is the case, we start the contracting phase, and then that often takes a couple of months. And then afterwards, at that point of time, somewhere in March, April next year, we really require your commitment by signing the consortium agreement. So till then, no legally binding commitment is required. And then hopefully we can kick off the project in April 2025. So for the coming 2 weeks, I ask you to make up your mind based on the discussion today. Am I still interested, yes or no? And if so, in both cases, please let us know. And when we have sufficient interest, we will start writing. A logic question is always how much commitment or how much investment as company do I have to make? At this point, we do not know. It heavily depends on the number of partners who will sign up for the project, the number of cases we will work on. So that will be defined in the period after June when we are writing the proposal. And of course, you will learn how much investment is required before we submit. And then based on that, you can give the firm commitment. So that is from the timeline and next steps point of view. I will put that in an email as follow-up.
Can I add one remark to that? It would be great if you in the email that you write back to Joost and us, that you also indicate any more questions that you have, because we didn't have enough time for discussion. So please drop all your questions in the email, and we will come back to you for that.
Yeah, no, for sure. And of course, we already shared with you an inventory form where we ask some questions to you. Some of you, the majority already send us feedback, but if you didn't do that and are still committed, please return that inventory form as well. Halak, we are running a little bit late, but feel free to ask your question.
Hello, sorry, I'm driving, so I cannot turn my camera on. Very quick one. What's the success of this from an impact point of view for businesses? So if we are partners of this, obviously it's depending on creating this model. Is the aim that in post the benefit for a business is that we can then use the model ongoingly for the successful model build for us to use them in our day-to-day. What's the end goal of this project in terms of, is there a way that we create the model that without compromising the confidentialities of data, we can still allow the models to be used by partners in their companies after the project is finished?
Yeah, I think so.
Yeah, so that should be the ultimate goal. What we often do, I have some experience before with other projects, is that we make the model accessible to the partners, at least for free for the first 2 years after the project, and then you can use it within your own organization. And after the 2 years, of course, we require some maintenance, etc., to keep up the model. After the 2 years, some cost will be involved, but at that point of time, you can also decide whether the model is still relevant and you want to continue, yes or no. But I think the arrangement we will make is that during the project and at least 2 years after the project, you have access. And afterwards, when there are sufficient partners who are willing to continue, we keep it online.
Okay,
Right.
thank you. I have a few follow-up questions, but I'd probably drop you an email about it in detail, not to
Sure.
take more time now. Yeah, thank you.
That's perfect. Any last question or remark? If not, I would like to thank you for your participation. I will follow up by email, and indeed, don't hesitate to drop any email with questions or request for further discussion. Happy to do so. Thanks a lot. Have a great day. Have a great weekend, and speak to you soon. Bye-bye.
Bye.
Thank you, Paul.
Bye.
Thank you. Bye-bye.
Goodbye.